co-founder and CEO Jensen Huang, who has no doubt AI is about to change everything.
It does quadrillions of calculations a second. It's just insane numbers.
Is it doing things now that surprise you?
We're hoping that it does things that surprise us. That's the whole point.
In a world where the laws of physics reign supreme, one company has dared to defy them. Nvidia, the titan of technological innovation, has unleashed a game changer, an AI chip that not only breaks boundaries, but exceeds them. How does this advancement challenge the fundamental principles of physics? And what implications does this hold for the future of artificial intelligence and beyond? Join us on this captivating adventure as we unveil Nvidia's breakthrough AI chip that defies physics. Nvidia, unveiling the future of AI. Only 4 companies worldwide have achieved a staggering market value of over $2 trillion. Microsoft, Apple, Alphabet, Google's parent company, and the computer chip manufacturer, Nvidia. Based in California, Nvidia's stock market value skyrocketed from $1 trillion to $2 trillion in just 8 months. This surge was fueled by the relentless demand for its cutting-edge technology, which powers today's artificial intelligence revolution. It's intriguing how a company established in 1993 to enhance video game graphics transformed into a 21st century AI powerhouse. In March 2022, Nvidia introduced the Hopper architecture, specially designed for data centers to power AI accelerators. The release of Hopper generated immense excitement in the AI community, and demand for these products soared during the AI frenzy of 2023. Due to shortages and overwhelming demand, customers faced a waiting period of 36 to 52 weeks for H100-based servers to be delivered after ordering. Remarkably, in the third quarter of 2023 alone, Nvidia reportedly sold a staggering 500,000 Hopper-based H100 accelerators. Nvidia's unrivaled position in the AI market with its Hopper products played a pivotal role in the company's market capitalization. Named in honor of the esteemed American mathematician David Blackwell, the Blackwell architecture pays tribute to his groundbreaking work in game theory, probability theory, information theory, and statistics. These mathematical realms have greatly influenced the design and training algorithms of transformer-based generative AI models. Notably, Blackwell holds the distinction of being the first African-American scholar to be inducted into the prestigious National Academy of Sciences. During Nvidia's investor presentation in October 2023, the company unveiled its updated data center roadmap, which now included references to its B100 and B40 accelerators, alongside the new Blackwell architecture. Previously, the successor to Hopper was simply referred to as Hopper Next on the roadmaps. Then at the Graphics Technology Conference, GTC, on March 18, 2024, Nvidia made the official announcement of the Blackwell architecture. Over 11,000 enthusiasts, including software developers, tech moguls, and delighted shareholders, gathered at San Jose's Pro Hockey Arena for a 4-day AI extravaganza. Their eyes were fixed on one man, Jensen Huang, the CEO of Nvidia. Huang explained that Blackwell transcends being just a chip. It's a comprehensive platform. While commonly associated with the graphic processing unit, GPU production, Nvidia pushed the boundaries beyond conventional designs. Hopper is the pinnacle of GPU advancement today, with Blackwell at its core. Hopper boasts an impressive 28 billion transistors, but what truly sets it apart is its architecture. For the first time, Nvidia seamlessly fused 2 dies, creating a unified chip that communicates at an incredible speed of 10 terabytes per second. No memory or cache issues hinder its performance. It functions as one colossal chip. When faced with skepticism about Blackwell's ambitious goals, Nvidia remained undeterred, resulting in the groundbreaking Blackwell chip. Blackwell seamlessly integrates into 2 system types. The first aligns flawlessly with Hopper, making upgrades a breeze, while the second, showcased in a prototype board, demonstrates its formidable power and future accessibility. Imagine a setup with 2 Blackwell chips and 4 Blackwell dies linked to a Grace CPU via lightning-fast connections, a configuration poised to redefine computing. According to Huang, what's truly remarkable about this computer is that it's the first of its kind, packing an incredible amount of computation power into such a small space. However, to push the boundaries even further, Nvidia needed a host of new features that could defy the limits of physics. That's where Nvidia's latest invention comes in, the 5th generation MVLink within the new Transformer engine. This engine, twice as fast as its predecessor Hopper, boasts computation capabilities within the network itself. Why is this crucial? Well, when you have multiple GPUs working together, they need to share and synchronize information. Having lightning-fast links and the ability to perform calculations within the network allows us to amplify performance significantly. Although it's rated at 1.8 terabytes per second, its effective speed surpasses even that, making it many times faster than Hopper overall. Compared to Hopper, it offers 2.5 times the performance for training per chip, thanks to its new FP6 format. Additionally, it introduces FP4, doubling the throughput for inference tasks. This is crucial for saving energy, reducing networking bandwidth, and optimizing time usage, which will be incredibly beneficial in the future of generative AI. Nvidia has called this era generative AI because it marks a significant shift in how we compute. Nvidia's new processor is tailor-made for this era, with a key feature being content token generation, facilitated by the FP4 format. This chip, housed within the Nvidia Blackwell AI supercomputer, offers 5 times the token generation and inference capability of Hopper. But why stop there? Nvidia is not satisfied with just this level of performance. That's why they've embarked on building an even larger GPU, surpassing the capabilities of the current one. The MVLink Switch, revolutionizing computing. The MVLink Switch is a remarkable chip boasting 50 billion transistors, almost the size of Hopper itself. With 4 MV-links, each operating at 1.8 terabytes per second, this chip enables every GPU to communicate with each other at full speed simultaneously. It's a groundbreaking advancement that pushes the boundaries of what's possible in computing, and thus you can construct a system that resembles this. This is the latest iteration of the DGX, a significant leap from what it was merely 6 years ago. Back then, the first DGX-1 boasted a modest 170 teraflops, or 0.17 petaflops. Fast forward to today, and Nvidia is looking at 720 petaflops, nearly reaching the exaflop milestone for training, a monumental achievement. This is the world's first exaflop machine condensed into a single rack. To put it into perspective, there are only a handful of exaflop machines worldwide at this very moment. This DGX isn't just any AI system, it's an exaflop powerhouse compacted into one sleek rack. Now let's delve into what makes this remarkable feat possible. The backbone of the DGX is the MV-Link spine, boasting an astounding bandwidth of 130 terabytes per second. To illustrate its prowess, consider that it surpasses the combined bandwidth of the entire internet. Remarkably, this feat is achieved without the need for expensive optics or transceivers, saving a significant amount of power, 20 kilowatts to be precise. In a rack that consumes 120 kilowatts in total, every watt saved makes a substantial difference. But what about cooling? Fear not, for this DGX is liquid-cooled, maintaining a comfortable temperature of 25 degrees Celsius as it operates. What goes in as room temperature comes out resembling a cozy jacuzzi at 45 degrees Celsius. With a flow rate of 2 liters per second, the cooling system ensures optimal performance without breaking a sweat. Now let's shift our focus to the heart of the system, the GPU. While some may envision a GPU as a simple component, to Nvidia, it represents so much more. Gone are the days of bulky GPUs. Today's GPUs are intricate marvels, comprising a staggering 600,000 parts and weighing a hefty 3,000 pounds. To put it into perspective, that's equivalent to 1.5 tons, an impressive feat indeed. Now imagine training a GPT model with 1.8 trillion parameters. Previously, this task would have taken 3 to 5 months with 25,000 amperes. With Hopper, it would require roughly 8,000 GPUs and consume 15 megawatts of power, completing in about 90 days. However, with Blackwell, the same task can be accomplished with just 2,000 GPUs and a mere 4 megawatts of power, an astounding achievement in efficiency and performance. Blackwell stands on the brink of becoming our most successful product launch to date, and the anticipation is palpable as we venture into the realm of Nvidia Robotics. Nvidia delves into the fascinating world of physical AI, where machines interact with the tangible world around them. Until now, AI has largely been confined to the digital realm, processing data within the confines of a single computer like the DGX system. But envision a future where AI transcends these boundaries, where robots possess their own intelligence and navigate real-world environments independently. This is where the magic of robotics ChatGPT moment unfolds. Nvidia has been hard at work developing end-to-end systems for robotics, including their AI powerhouse, DGX for training models, and AGX, the world's first robotics processor, designed for high-speed sensor processing in low-power environments. Bridging the gap between the digital and physical worlds is Omniverse, Nvidia's virtual world simulation engine hosted in the Azure cloud. It's a fully autonomous warehouse bustling with activity where humans and forklifts interact seamlessly under the watchful eye of the warehouse, serving as the ultimate air traffic controller. This intelligent system ensures everyone's safety by directing traffic and providing guidance through the warehouse. And yes, you can even converse with this futuristic warehouse. What's more, all of this operates in real time. Each robot is equipped with its own autonomous robotic stack, making the entire process efficient and seamless. With Blackwell leading the way, the future of robotics is within reach. Let's dive deeper into the wonders of robotics. The future of humanoid robotics. Soon, the dominance of robotics in various industries seems inevitable. It's a safer and more convenient option. Among these, the automotive sector is poised for significant transformation. In the coming year, Nvidia will collaborate with Mercedes, followed by JLR, to integrate their cutting-edge technology. Huang announced that BYD, the world's largest electric vehicle company, will adopt Nvidia's latest innovation, Thor. This next-generation AV computer designed for transformer engines will drive the future of robotics, potentially leading to humanoid robots. In a groundbreaking move towards advancing humanoid robotics, Nvidia has launched Project Groot, a pioneering initiative set to redefine the landscape of robot learning. Going beyond mere imagination, Nvidia is delving into the realms of invention and exploration, pushing boundaries to unlock the full potential of humanoid robots. Project Groot represents a crucial leap forward in the field of robotics, offering a comprehensive foundation model capable of processing multimodal instructions and past interactions. This model, equipped with sophisticated algorithms, enables humanoid robots to autonomously determine their next actions, bridging the gap between human commands and robotic execution. At the core of Project Groot lies Isaac Lab, a specialized robot learning application developed by Nvidia. Leveraging the power of Omniverse Isaac Sim for simulation, Isaac Lab provides a virtual training ground where humanoid robots can refine their skills and adapt to various real-world scenarios. Complementing Isaac Lab is Osmo, a new compute orchestration service that seamlessly coordinates workflows across Nvidia's advanced DGX and OVX systems, ensuring efficient training and simulation processes. One of the most remarkable features of Project Groot is its ability to learn from minimal human demonstrations. By analyzing a handful of human interactions, humanoid robots equipped with Project Groot can adeptly assist with everyday tasks and mimic human movements with astonishing accuracy. This breakthrough is made possible by Nvidia's state-of-the-art technologies, which leverage advanced neural networks to understand human behavior and translate it into actionable instructions for robots. Furthermore, Project Groot enables humanoid robots to generate motions based on natural language instructions, further enhancing their versatility and usability. Whether it's giving high fives or showcasing intricate maneuvers, humanoid robots powered by Project Groot demonstrate an unprecedented level of intelligence and adaptability. Driving the capabilities of Project Groot are the new Jetson Thor robotics chips, meticulously designed by Nvidia for optimal performance in humanoid robots. These chips serve as the backbone of Project Groot, providing the computational power needed to bring humanoid robots to life and propel them into the future of robotics. As humanoid robotics continue to evolve towards greater autonomy and capability, Project Groot stands at the forefront of innovation, paving the way for a new era of AI-powered robotics. With Nvidia's unwavering commitment to excellence in software development and cutting-edge technology, the possibilities for humanoid robots are limitless, promising a future where robots seamlessly integrate into our daily lives, revolutionizing industries and reshaping the way we interact with technology. Now let's delve into the fascinating journey of how Nvidia evolved into the mighty tech giant we see today. The Nvidia evolution. The 1990s were marked by fuzzy TV screens, dial-up internet, and beige computer boxes. Those who grew up in this decade witnessed the evolution of personal computers. In the early 90s, rendering a file browser window or blocks of text was pretty much all the graphics you needed. CPUs were powerful enough for these tasks, unless you were in animation or engineering, where more complicated graphics were required. For those seeking advanced graphics, video game consoles were the go-to solution. However, a trio of engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, hailing from sunny California, had a different idea. They envisioned a separate hardware processor that could easily bring graphics to personal computing. Their brainstorming sessions at a local Denny's, fueled by endless cups of coffee, led them to a critical realization. CPUs, as the heart of computers, were designed for serial processing, capable of tackling only one task at a time. However, generating 3D graphics for games demanded repetitive, math-intensive tasks that strained CPUs. Their solution? A separate chip capable of parallel processing, a game changer in computing. This chip would divide complex tasks into smaller ones and execute them simultaneously, significantly boosting efficiency, especially for tasks like rendering 3D graphics. This innovative chip, later known as a GPU, wouldn't replace the CPU, but would complement it for graphical tasks. This idea laid the foundation for Nvidia and would go on to revolutionize not just computing, but also computer science over the next 2 decades. But at the time, Nvidia's focus was squarely on enhancing the gaming experience on PCs, a market with immense potential. Thus, in 1993, in a condo in Fremont, California, the journey of Nvidia began. Nvidia was established with the innovative concept of integrating parallel processing GPUs into home computers. Interestingly, the name Nvidia is a blend of NV, derived from next version, and Nvidia, which means envy in Latin. The choice of green in their logos symbolizes the envy they hope to evoke due to the immense computing power their chips would deliver. The brains behind Nvidia were top-notch engineers. Jensen Huang, a Taiwanese-American electrical engineer, brought extensive experience as the director of coreware at LSI Logic and as a microprocessor designer at AMD. LSI Logic played a crucial role in Nvidia's early journey. Alongside Jensen Huang, the company's co-founders included Chris Malachowski, who brought valuable engineering experience from HP and Sun Microsystems, and Curtis Preem, a former graphics chip designer at IBM and Sun Microsystems. While being skilled engineers was advantageous, launching a startup posed its own set of challenges, as the Nvidia founders soon discovered. In 1993, they found themselves at a crossroads, unsure of how to proceed. Seeking guidance, they enlisted the help of a lawyer to assist with the company's incorporation. With just $200 in hand, Huang took a bold step, investing his modest sum to kickstart Nvidia's journey. This initial investment not only paved the way for the company's incorporation, but also secured Huang a 20% stake in Nvidia. The next hurdle was securing funding to fuel their ambitious vision. From skepticism to success, convincing venture capitalists proved to be an uphill battle. Rather than polished business plans, investors looked for founders with a track record of success and a compelling vision. Despite the challenges, Nvidia eventually caught the attention of Sequoia Capital and Sutter Hill Ventures, securing a substantial $20 million in funding. To many, this level of funding may seem extraordinary for a fledgling company. However, it was Huang's prior connection to LSI Logic that played a key role. Leveraging his ties with LSI Logic's CEO, Huang arranged a meeting with Sequoia Capital, a venture firm that had previously invested in LSI Logic. Despite initial skepticism, Sequoia Capital ultimately took a chance on Nvidia, recognizing the potential in the burgeoning graphics card industry. This initial investment of $2 million was followed by an additional $18 million, propelling Nvidia towards future success. Back then, deciding to invest in Nvidia was a risky move. There were 89 other companies eyeing similar goals, but only AMD and Nvidia managed to survive the competition. When Nvidia went public in 1999, its value soared to $600 million, making the initial investment pay off handsomely, multiplying by a staggering 100 times. But let's not jump ahead too quickly. At this point in the tale, Nvidia was merely a small team of engineers. With the funding in hand, it took them 2 years to assemble a team and develop their inaugural product, the NV1. Launched officially in 1995, the NV1 marked Nvidia's entry into the market. During the NV1's development phase, Nvidia struck a deal with Sega to produce chips for their gaming consoles. These chips were meant for popular games like Virtua Fighter and Daytona. Interestingly, the NV1 chips were also compatible with computers, allowing gamers to enjoy Sega Saturn games directly on their PCs, a revolutionary concept back in 1995. Nvidia made a bold choice by adopting a quadrangle-based image rendering architecture for their NV1 chips, a decision that Sega wasn't too thrilled about. Despite Sega's objections, Nvidia's leadership stood firm, refusing to alter their course. But why did they opt for rendering polygons in quadratics instead of triangles? The rationale behind this choice is explained in a video by Lazy Game Reviews. Using quads or squares instead of triangles was aimed at speeding up rendering by lightening the load on the CPU. In theory, this approach meant fewer polygons and better rendered rounded objects. It provided the flexibility to create shapes with squares rather than being restricted to triangles everywhere. This strategy made sense at a time when CPU speeds and memory clocks were relatively low, as it offered improved rendering for certain objects or models in games. However, as technology advanced and memory capabilities improved, this approach became less practical. Additionally, it posed compatibility issues, as there was no support for OpenGL, a widely used graphics API. Nvidia and SGS Thomson even expressed skepticism about the necessity of OpenGL for consumers. Furthermore, when DirectX and Direct-to-3D emerged, the NV1's rendering through quads posed further limitations. Nvidia attempted to address this with a software patch, allowing the NV1 to run DirectX but only in software mode, negating its hardware acceleration capabilities. Despite its innovative approach, the NV1 project ultimately failed to make a significant impact. It aimed to be a versatile solution, combining 3D graphics, video, audio processing, and more into a single chip. However, as Nvidia's CEO Huang later described it, the NV1 was similar to an octopus, complex, multifaceted, and possibly ahead of its time. In the end, it failed to capture the market's attention. The market demanded something simpler, a dedicated 3D graphics chip, not an all-in-one solution like the NV1 chip. Moreover, the NV1 was perceived as overpriced compared to its competitors. To exacerbate matters, the industry was shifting, with Microsoft introducing DirectX, a new API that favored a triangle-based standard for 3D graphics rendering. This made coding for graphics easier for developers, leading them to embrace Direct. Unfortunately for Nvidia, the NV1 chip was incompatible with DirectX, causing many existing games to suffer from performance issues or become unplayable on Nvidia's new chip. This incompatibility dealt a significant blow to Nvidia, with their customer partner Diamond Multimedia returning the vast majority of the 250,000 NV1 units they had purchased due to poor sales and lack of game support. This return nearly bankrupted Nvidia, resulting in the layoff of 40 out of 80 employees and leaving them with a surplus of unsellable chips. It was a disastrous situation, amounting to a $10 million loss. Amidst this turmoil, Nvidia was developing the NV2 chip for Sega, which was also based on the same outdated quadrangle architecture. Realizing the need to pivot to survive, Huang made a bold move: Nvidia's advancements and transformation. Huang approached Sega's CEO with a request to be released from the contract, but with full payment. This money was crucial for Nvidia to stay afloat. In an act of extraordinary kindness, Sega's CEO agreed to Huang's request. This generosity allowed Nvidia to redirect its focus and resources toward a path that aligned with the industry's direction. Had Sega pulled out their investment at that critical time, Nvidia would have faced extinction. Nvidia's experience with the NV1 was a crucial lesson in their journey. It underscored the importance of understanding customer needs and market trends, shaping Nvidia's future strategy. It's quite astonishing how close Nvidia came to failure, especially considering its current value of over $1 trillion. However, the decision to heed market feedback and concentrate on personal computers marked the beginning of their extraordinary success story. Following their setback, Nvidia decided to re-enter the PC industry with a more direct approach. The timing was ideal, with the PC market flourishing. In 1999, Nvidia introduced the GeForce 256 graphics card, which wasn't just successful, it transformed the industry. As the first programmable graphics card, it also popularized the term GPU. This breakthrough enabled gamers and developers to explore new creative avenues with advanced shading and lighting effects, significantly elevating the gaming experience. Capitalizing on this success, Nvidia went public in the same year. By 2000, they had secured a significant deal to develop graphics hardware for Microsoft's Xbox game console. This deal provided Nvidia with a substantial $200 million advance, a considerable leap from their previous console endeavors with Sega. The Xbox made its debut in 2001, powered by a specialized chip known as the NV2A, custom-made by Nvidia. This success served as a springboard for Nvidia's prosperity throughout the 2000s. They played a pivotal role in shaping the processors for Sony's PlayStation 3, while also garnering the attention of major players in the computer industry like Apple, Dell, and HP, who started incorporating Nvidia's GPUs into their products. The company's growth trajectory seemed unstoppable, thanks to a combination of strategic decisions and innovative technologies. One of Nvidia's key strategic moves was to position itself as a fabless chip company. But what does that mean? Essentially, fabless chip companies design the chips but outsource their manufacturing. Huang was adamant about this approach, seeing it as a way to significantly reduce costs. For the past 3 decades, Nvidia has partnered with Taiwan semiconductor manufacturing company, TSMC, the world's leading semiconductor foundry. TSMC's state-of-the-art manufacturing capabilities have been instrumental in Nvidia's ongoing success. As Huang himself acknowledges, Nvidia owes much of its achievements to TSMC's pioneering work. While Nvidia focused on chip design, outsourcing manufacturing allowed them to channel resources into innovation. They broadened their horizons beyond gaming chips and graphics, recognizing the immense potential of GPUs and their parallel processing power. Nvidia aimed to empower developers with the tools and software needed to unlock the full capabilities of the GPU. In 2006, they introduced CUDA, a software toolkit that revolutionized parallel computing by harnessing the power of GPUs for a wide range of applications. Before CUDA, programming a GPU was quite cumbersome and daunting for coders. It involved delving into complex low-level machine language or APIs, which often proved to be a headache. However, CUDA changed the game by making it much simpler to write programs that could utilize GPU power using familiar languages like C, C++, and Java. This innovation had a profound impact, extending far beyond just graphics applications. It opened up the potential for numerous sectors dealing with vast amounts of data to harness parallel processing power. The trend gained momentum in 2008 when the Tokyo Institute of Technology utilized CUDA-accelerated GPUs for their supercomputer, achieving remarkable performance. Since then, many other data centers, including Amazon Web Services, Google Cloud Platform, and Netflix, have embraced GPUs for diverse applications such as cloud computing, machine learning, video streaming, and web search. However, the real breakthrough came with the AI explosion in 2012, the GPU revolution. A crucial moment came with the emergence of AlexNet, a groundbreaking deep learning neural network. Developed by Alex Krzyzewski, a PhD student at the University of Toronto, AlexNet leveraged the power of GPUs to significantly enhance computing efficiency. By connecting 2 Nvidia GeForce GTX 580 gaming cards to his computer, Krzyzewski processed AlexNet's neural network with an extensive dataset of 1.2 million images. The results were astounding. The image recognition accuracy showed a remarkable improvement, with a 15% error rate compared to the previous year's 25%. While these figures may seem modest by today's standards, it was a significant milestone at the time, laying the groundwork for the sophisticated AI tools we now take for granted, such as ChatGPT, Google Gemini, and Google Lens, which boast far superior accuracy. However, in the past, this event was nothing short of revolutionary. It marked the beginning of a new era, shattering the long-standing skepticism surrounding neural networks and triggering what was known as the AI winter. For decades, experts had dismissed the practicality of neural networks, but the success of this event proved them wrong. The Nvidia GeForce GTX 580 cards played a significant role in this revolution. Optimized for CUDA, they paved the way for implementing parallel algorithms, making them indispensable for deep learning tasks like those performed by AlexNet. Suddenly, a vast array of possibilities in deep learning applications emerged, and Nvidia was at the forefront of this transformative moment. Their strategic investment in CUDA and its surrounding software ecosystem began to pay off significantly. Nvidia GPUs quickly became the gold standard for training and deploying generative AI and large language models. For instance, OpenAI, renowned for ChatGPT, relied on Nvidia's A100 series GPUs for the swift and widespread deployment of their AI models. Following ChatGPT's explosive debut in November 2022, major tech companies rushed to acquire Nvidia's GPUs, igniting a frenzy of demand. The A100 GPUs in particular flew off the shelves, with Microsoft alone procuring a staggering 10,000 units. Each A100 unit came with a hefty price tag of $110,000. Yet Nvidia sold hundreds of thousands of them. The unprecedented demand propelled Nvidia's sales to soar to $13.5 billion in the quarter ending July 2023, marking a staggering 101% increase from the previous year. On May 25th, their stock market value surged to $184 billion in just one day. And on May 30th, 2023, Nvidia achieved a monumental milestone by becoming the 6th company in the world to reach the coveted $1 trillion market cap. Today, Nvidia's market cap is over $2 trillion. What do you think about Nvidia's new technology? Let us know your opinion in the comments below. And if you enjoyed watching this video, make sure to give it a thumbs up and subscribe to the channel.